Let us obtain a solution for this question. We are told that the sum of the first two terms of a GP, a geometric progression, is P, and the sum of the last two terms is Q. If the GP has n terms, the common ratio is question mark. We have a list of these options. Let us check which one gives the correct answer. Okay, just as you know, for any geometric progression, the nth term, each term of the geometric progression Tn is defined as Tn is a r n minus 1. Of course, n is the number of terms, and a is the first term, r the common ratio. Okay, so if we are told that the first two terms of the GP is P, it means that T1 and T2, by the time I add those two terms, I get P. But what exactly is T1? Of course, T1 is just A, and T2 is a R. Okay, so the sum of these two terms gives P. So I can also equally write A plus AR equals to P, or invariably A into 1 plus R equals to P. Okay, so I can say this is my equation 1. All I've done is factorize A. Okay, so from the second statement, I am told the sum of the last two terms is also Q. Now, what will be the last two terms? Of course, the last term will be the nth one, the last one. So Tn, we are told that the GP has n terms. So this n gives the last term, and that term is just AR n minus 1. Yes. So it means the term preceding this one, that is the second to the last term, would be Tn minus 1. Okay? And going by this same formula, that should be AR. Now, n is not just n anymore, it is n minus 1. So it is n minus 1 minus 1, and that will be AR n minus 2. So this will be the second to the last term. So the sum of these two terms now gives me this Q, the Q. So it means that AR n minus 1 plus ARn minus 2 is equal to Q. I can also change this and say ARn minus 2. Careful, I have altered this part. Okay, so what I will do to annul that effect, I can say multiplying R. Of course, this multiplying by R will still make this become n minus 1 plus ARn minus 2 equals to Q. Of course, now I see that ARn minus 2 is a common term. I can factor that out. So this becomes ARn minus 2, R plus 1 equals to Q. And this gives equation 2. Now, what I will do now is to divide equation 2 by equation 1. So, equation 2 divided by equation 1 becomes ARn minus 2, R plus 1, all over divided by equation 1, A into 1 plus R, and that should be Q over P. Of course, looking at this side of the equation, this is common, so that can just annul themselves. The same thing will happen with A. So all I'll be left with is R to the power of n minus 2 equals to Q over P. Okay, so now all I need to do is to get rid of that index with R. Okay, so to do that, I can just say take the roots Rn minus 2 to the power of 1 over n minus 2 on both sides, and that will be Q over P to the power of 1 over n minus 2. Like this cancels this. Finally, my R becomes Q over P 1 over n minus 2. And looking through my options, I see that the correct answer is option D. Okay, so that is how we go about this question. Thank you, and I'll meet you in the next one. Adios.